Welcome to a presentation about ZD&T. It is called ZD&T Survival Kit. This is not authorized IBM material, but the concentrate of the experiences from several customer projects in various countries done by IBM and Exact Consulting. You should use them carefully and with common sense. Also, this is not a full ZD&T course, but should only be seen as a survival kit. And most important, the system you break will be your own. This is a short speaker introduction. The objectives of this session are to provide an overview over ZD&T, both as logical and physical views. We will explain how to run an implementation project and which challenges to handle. Finally, we will look at a long list of helpful commands and files to check and modify the system. This session is not intended to be an introduction to ZD&T. But could I please have a show of hands? How many of you are already familiar with what ZD&T is? So, what is ZD&T? ZD&T means IBM Z Development and Test Environment. It has had several other names over the years. ZD&T is a ZOS or ZVM system running on emulated Z14 processors, hosted on Intel hardware. Emulated hardware means a package, which seen from below it is a bunch of Linux programs. Seen from above it appears as a Z14 machine. The software, on the other hand, is real. It is a complete ZOS system, ready to run out of the box. It is intended and licensed for test and development, not for production. That also implies that you cannot use it to compile for production. That must happen on your big iron systems. ZD&T is available in 3 flavors. Personal Edition is the common name for the server version and the single-user version. Enterprise Edition contains tools for deploying, provisioning and configuring ZD&T systems. Parallel Sysplex Edition supports a parallel Sysplex configuration under ZVM. We will start with a logical view of ZD&T. At the bottom we have the hardware platform, which can be a physical Intel machine, a VMware workstation on a Windows machine, a VMware or similar instance, or a virtual machine in a cloud service. The hardware must be 64-bit Intel processors. It is up to you to provide this. Going one layer up, the Linux operating system is normally a Red Hat Enterprise Linux, which is an officially supported configuration. ZD&T has recently added Ubuntu as a supported distribution, but is also known to run on other Linux distributions. In any case, it must be a 64-bit Linux. The Linux layer is also your own responsibility. The next layer is the Z-series hardware emulation. Z1090, and its twin Z1091, are Linux programs, which do the emulation. The latest version emulates Z14. This is supplied by IBM in North Carolina. The ZOS operating system and subsystems are supplied as a package called ADCD, Application Developers Control Distribution. It consists of disk images. It can IPL out of the box. It is supplied by IBM Dallas. We at Exact like to add an instance-specific configuration volume to the supplied package. Here we store anything specific to an instance, such as TCP/IP names and addresses, system name-related members, and similar members. This must be created and mounted by yourself. Host data and applications must be downloaded from the big iron or created synthetically. We prefer to have download volumes and active user volumes separated. This is the part of the effort that requires most effort by the user. My colleagues and I like to refer to the figure you have just seen as the lasagna model. On one hand it visualizes the parts of a ZD&T system. On the other hand, it also serves as a design guide to prepare a system for later upgrades and maintenance. The general idea is that you should design the system so that you can swap different layers as independent of each other as possible. Continuing to the physical view of a ZD&T system, this is the classic way to set up a ZD&T farm. It is shown as physical servers, but in reality, you would prefer a VMware farm or a cloud provisioning with data on a SAN. In this example, we have installed and configured a generic system image on a machine called XA00 and then created specific instances for different teams and requirements. System images can be stored on the file share, so a team can shut down its system and put it in the refrigerator to let another team use the instance and its license. The licenses are provided from a separate license server. This example shows a single-user system. We are using a laptop with a 64-bit Windows operating system. Linux and ZD&T are running inside a VMware workstation package. The license is provided by a locally attached dongle. The cost for servers and single-user systems are quite different from each other. And so are the use cases. Otherwise, it is the same ZD&T system we are discussing. IBM now supplies a product called ZD&T Enterprise Edition, which contains a toolbox with a web interface. You run the tools on a separate server, and its intention is to make installation and configuration much easier. Developing this product is a big and complicated task, so it must be seen as a work in progress. It looks very promising to me, but still has its limitations. This is a ZD&T farm scene from a VMware console. From here it just appears as a bunch of virtual servers running Linux. If you choose to run ZD&T in the cloud, you have the usual self-service panels to order and configure the system. If we go one layer up, we can look at the system from inside the Linux server. Here we have the master console and a channel-connected 3270 terminal. We also have the Linux command window where we have started the hardware emulation and done an IPL. Moving up another layer, we have ISPF running in a terminal emulator. It should look familiar to you. After all, it is just another ZOS system. Here is another ISPF screen with a dataset list. And here is the ISPF editor. SDSF also looks like itself. If you prefer to use a modern interface like IDZ, then ZD&T still looks the same as the big iron. The license server provides a display of connected ZD&T systems. Here we just have one active instance. ZD&T Enterprise Edition supplies a set of tools to assist you in installation of Z1090, ADCD, and the network configurations. This is the web interface. Now we have seen what ZD&T looks like and how it is structured. Let us discuss what you can expect from a ZD&T system. ZD&T is a complete and real ZOS, or ZVM, system, where almost everything is the same as on any other ZOS system. Therefore, the functional answer to "can you do this or that" is almost always yes. It is a great platform for development and test, because you don't have to wait for change management and RACF administrators, and you can easily restore a changed or damaged system to a previous stage. You can even add zip and crypto processors. ZD&T is indeed very buzzword compliant. It is a well-suited platform for DevOps, shift left, agility and flexibility. ZD&T is only licensed for use for development and test. IBM does not want to devaluate the rock-solid Z-series platform by running ZOS on inferior hardware. It is not suited for performance testing. It has many layers of virtualization below your application, and there are no system assistance processors or physical channel adapters to handle I/O. You should not run large Java workloads, although ZOS version 2 and ZD&T version 12.03 offers improvements. The Z14 code set is almost complete. Only some obscure crypto instructions and very few others are not handled. There are some hurdles to overcome. Each version of ADCD supplied by IBM Dallas is a little different. This is not an inconsistency. It is just that they have to fit many systems together, and that they try to react to customer requirements. Most of the latest changes seem to be caused by their improvement of the parallel sysplex support. They also have to make compromises to the many different configuration we as customers use, such as which subsystems are configured and active, which versions of ZOS and subsystems are supplied, and how do the subsystems like CICS, IMS, DB2, MQ, System Logger etc. play together. Another big hurdle is your decision on how you want to keep ZD&T versions in sync, both with new ADCD versions and with the maintenance and improvements on your big iron. The third big hurdle is how you decide to keep data and applications in sync with the big iron. Let us proceed to discuss how to run an implementation project. We will run quickly through a lot of material, which mostly is meant for you to put in your backpack for survival. But please stop me when there is something you wish to discuss further. These are the phases of such a project, as we see it. We will discuss each of them now. The preparation phase starts when you have decided to run a proof of concept or a pilot. Most of the activities in this phase are practical and technical, but the most important one, and the most difficult one, is to identify a committed team that can see its advantages in using ZD&T. After the preparations, you should run a workshop with all stakeholders to identify the requirements and establish a consensus on the project goals and success criteria. Next follows a technical phase, where the baseline system is installed. The most difficult part of this phase is to establish network connectivity, especially when crossing firewalls and demilitarized zones. The next one is partly a design phase, where a lot of decisions need to be made. Then they need to be implemented in the ZOS configuration. Third-party software can take quite a while to sort out. When the system has been tailored to your requirements follows the most challenging phase. Integrate host data, applications and configurations. It is important to distinguish between development and test scenarios, as they require quite different systems. Here we need a number of smaller workshops and the active assistance of both technical and application staff on the big iron. It ends with a system test done by technical staff. Let us quickly go through some details of the tasks now. This is a list of tasks to integrate ZOS. We will not go in further details here, but you can catch me later during this week for further discussions. This is the list for MQ. MQ is probably the easiest part. This is the list for CICS. Definitions are normally simple, but it can be challenging to port special customization of CICS startup or log on. An example is SVC screening, that also impacts ZOS. DB2 is either a small or a large task, depending on how much you want to change from the version installed in the turnkey system. IMS requires very precise information from the staff on the big iron, since there often can be very special customizations in the existing system. If you need to use third-party products on your ZD&T systems, you should start early to confirm licenses and cost with your vendors. In our experience, they can be very different from each other, and sometimes more costly than ZD&T itself. This is a short list for data. It would take several hours to go into details about DB2, but this can give you an idea of the issues involved. This is the list for applications. The biggest challenge for development scenarios is normally to have all dependencies bundled with the source. The biggest challenge for test scenarios is normally not having corresponding timestamps between load libraries and DBRM libraries. Based on the decisions made and the lessons that you have learned, it is now the time to design and start building the long-term system. In parallel, you must develop processes and tools for operations and maintenance. And you must establish an in-house support team with the project participants at the center. Finally, the project team must hand the system over to the staff running the daily work in the future, and a final acceptance milestone should be passed. Let us discuss a few special challenges that we have met during such projects. IBM supplies a ZD&T system that is ready to run. But the effort to adapt it to your environment is a big effort, and it is not easy to understand that this is primarily an organizational task modernizing the way we work. There are many technical tasks, such as customizing the ZD&T ZOS system to your environment. But it takes much more to identify, isolate, extract, copy and integrate applications, data and configurations from the big iron to ZD&T, and to establish maintenance and operations and prepare for future system upgrades. Very often there are many application dependencies of system and subsystem names on the big iron, left over from the days when each mainframe system was an isolated island, and mergers and outsourcing were not the rule of the day. We strongly recommend that you remove such dependencies before copying to ZD&T. That is an effort you should do anyway to be able to modernize your systems. If you don't, there will be many decisions to make and many tasks to do. The data and application upgrade strategy is closely connected to your source control management, your test data management, and your application lifecycle management. This is a list for development scenarios. And this is a list for test scenarios. Next, we will mention the system upgrade strategy. Do you want to stay in sync with the big iron? Or to follow the AD/CD package deliveries? Or do you want something in between, like periodically coordinating PTFs with the staff on the big iron? You should especially be aware that swapping AD/CD packages impacts DB2 and RACF in particular. Finally, some advice on security. As a general principle, we want to support agility and flexibility. This requires more freedom for developers and testers than the big iron can allow. We will need to cleanse the data and the applications before copying them to ZD&T. The ZD&T system is ZOS, so internally it has the RACF security you know and perhaps love. Physically it is an Intel system with perhaps half a terabyte of data, so it can more easily be stolen than a big box. You should have separate RACF systems and definitions on ZD&T. Do not copy the big iron RACF database. In the data area, you should anonymize or filter data, or both, before copying. Be careful not to confuse pseudonymization with anonymization, but be careful to be compliant with GDPR. Do not store any critical data on ZD&T. Do not copy any password files. In the applications area, you should be aware of handling confidential code, such as defense systems, fraud detection, and other critical and competitive advantage-related algorithms. You might also have to handle situations where one team must not see code or data from another team. This would be solved by having separate ZD&T instances with separate RACF definitions, or by serializing their access to the ZD&T instance, while storing away the image of one team, and loading in an image of the other one. We have found in almost every case that it is difficult to agree with the staff on the big iron on processes and tools for copying to ZD&T and for promoting changes from ZD&T. Words like agile and flexible runs counter to their instinctive prime directive of securing stability on the big iron. The last part of the session will discuss how to survive the journey. We will supply a lot of tips, tricks, commands, and interesting members to investigate. You will need to dig further into each of them afterwards on your own. We will work our way through the layers from the bottom upwards. In VMware you should use the administration panels to manage the areas mentioned. A standard ZD&T configuration would use 4 processors in VMware. 1 is used by Linux, and the 3 others by z/OS. We will now compare this with a special configuration made for a test installation of ZAO. The special configuration has 8 processors in VMware. This is the device maps for the 2 configurations. The standard one has 3 processors for z/OS. The special one has 4 general-purpose processors, 2 zip processors, and a cryptographic coprocessor. This is the startup of each system, as seen from Linux, which confirms the processor setup. In SDSF you can select a system display, where we can see the number of general-purpose and zip processors. In the ICSF panels in ISPF you can see the active cryptographic coprocessor. Moving up to Linux, here is a list of commands to get the underlying hardware, to get the Linux version, to display the file system, and to install some of the products needed. Networking can be handled using these commands and files. There is a lot of documentation on Z1090 and Z1091 in the ZD&T Redbooks. Here are a few of them. Here are some useful Linux commands for setup verification. It can happen that you accidentally close the master console window in the Linux view. This is how to fix it. First create a X3270 terminal. If it is available as a Linux menu item, then you can use that. Otherwise you can start one from a command line. If you have a running TSO session you can use the very commands from SDSF. Otherwise use the operator message command from a Linux command line. Let us move up to z/OS. Here are a few tips and commands. We will look deeper at the display IPL info command. Using display IPL info from the console responds like this. Note the lines marked in yellow. They are the keys to drilling down through the z/OS system configuration. This is a graphical view of the main configuration artifacts. We start from the run zpdt Linux script and the device map. They specify which IPL parm to use. The IPL parm specifies the parm-lib concatenation and the master catalog. The parm-lib member called IEA something specifies the next level of information used to IPL the system. Notably the master JCL member specifies the proc-lib concatenation. The graphic continues on this slide, where we can see the VTAM and TCP/IP configuration members. Among the specifications in the IPL parm member is the syscat instruction. It specifies which master catalog to use. In this case it is catalog.z23b.master. The master catalog contains datasets needed at IPL time and all the user catalogs. Each user catalog contains aliases for all other dataset high-level qualifiers. We like to have a user catalog on each of the user disks we define to the system, and to have all datasets on that disk defined in that user catalog. that allows us to copy disks from one ZD&T system to another and import the catalog there. This is a list of all the members that we normally edit when we do the first configuration of a new ZD&T system. You could use it as a checklist. IBM provides an unofficial, unsupported product called Tacid, which runs inside ISPF. It is a great tool for systems programming, and it is available for free at the address given. Installation is very easy. When we have the system up and running, we like to create an LPAR-specific configuration disk. We use it to separate what is in common for all ZD&T instances from what is specific to each. This will make cloning and maintenance easier. We like to rename each LPAR, which by default is called S0W1. This enables us to see where we are, so we do not by accident change a system that users expect to be stable. If you want to rename the LPAR, you need to edit these members. To rename an LPAR, you also need to do these actions. You should consult a manual before each of them, if you don't know very well what you are doing. And you should definitely back up the system before doing any of the changes. Be very careful. They say that real men do not take backups. I believe that real men weep a lot. Here are some tricks to maintain syslog and logric. The first two bullets are configuration changes, while the last bullet is a handful of useful commands. You should learn about them before you suddenly need them. The system is by default set to an American time zone. The central place to change it is the parmlib clock member. You also need to change several places in the Unix file system. Here is a time zone specification for Unix that handles daylight saving time until we can get rid of it. The Unix file system is an add-on to ZOS. You define it as a linear VSAM file, and you can split it over several disks. When you mount it as a file system in Unix System Services, it appears as a hierarchical structure of directories and files. Program objects often exist as an 8-character load module with a symbolic link with the full Unix name, which can be 255 characters. You can maintain them from batch or using the tsoish command. This is the extended subset of branches in the Unix file system for your reference. ZD&T comes pre-configured as a JES2 system. To use JES3 as the primary job entry subsystem, you must specify JES3 in the parmlib member called IEFSSNXX. Here is a list of members to modify to run JES3. Two of the most difficult parts of DB2 configurations is to rename a DB2 subsystem and to change the code page. To rename a DB2 subsystem, you seem to need to install a separate subsystem and use that instead of the IBM supplied one. This includes storage definitions in SMS. To change the code page on a DB2 subsystem is not that complicated, but if you get it wrong, you might need to reinstall the DB2 disks to repair it. Here are a few things to do to finish the configuration of your CICS system. IMS Connect and ODBC are not defined and not activated by default. The IMS catalog is not configured. And for IMS SPOC you need to do some work. Here is a list of members to edit in order to rename an IMS subsystem. IDZ comes partially configured with ZD&T. You need to change the Java home environment parameter to an existing Java version. The debugger is not configured, and neither are some of the PD Tools products. You need to validate your license conditions with IBM before activating. The SMPE environment is incomplete, as some of its datasets are missing or too small. They need to be defined to apply PTFs to IDZ. ZOSMF is a management tool, which now is enabled by default in ZOS. It is very useful, but also very CPU hungry. Here are some suggestions for it. When all these tasks have been done, and all the errors have been fixed, you have baked a fully functioning ZOS system that can make your development and test efforts more flexible, efficient and agile. Now comes the time to play with your own system. Here is some further documentation. We have now provided an overview over ZD&T, both as logical and physical views. We have seen how to run an implementation project and which challenges to handle. And we have rushed through long lists of hints and tips and tricks and helpful commands and files to check and modify the system. Are there any more questions? You can use the conference app to ask further questions in writing. Or you can catch me after the session, if you have more questions.
Please complete the session evaluation.